So today I'll conduct your week one problem solving and doubt clearing session for this course, Digital Circuits. So this is taught by was taught by Professor Dr. Santanu Chattopadhyay from IIT Kharagpur. And I'm Calvin Joseph, and I'm a research scholar from IIT Kharagpur, though we are from a different department. Okay. So in this course, like this is the course content which you will be having, where we'll be focusing on that. This is a 12-week course, and there is introduction. We will discuss about electronics, then about number systems. Then we will also discuss about Boolean algebra. And okay, I have a feeling that the Zoom can only accommodate 100 people. So maybe that's the limit. So maybe if your friends are joining, probably the limit has been reached. So I think I'll try maybe where the next time I can buy Zoom Pro so that everyone can be accommodated. Okay, but for now, I think today only 100 people can join. Okay. So today, this is the outline of this week. So we'll have introduction, number systems, then Boolean algebra will be there. Then there'll be something as combinational functional minimization, like how to use K-map. Then there are certain theorems, certain identities of Boolean algebra, which is a different algebra which we use for digital circuits. So that also you will learn in this course. Okay, they are simple. It'll take some time to get a grasp of it, but once you get a grasp of it, it becomes easy for you to apply. And those are, the fundamentals which you need when you work with digital circuits. Okay. Then you also have logic gates. You would have known AND gate, OR gate, etc. But you will have a recap about that. Then various arithmetic circuits such as adder, subtractor, those things that we deal with. Then you have what is known as multiplexers, decoders, etc. Now, from the basic building block of logic gates, then you have some arithmetic circuits. Then you have certain various logical operations which you need to do, and some operations you need to do it in different contexts. So when you have different contexts, you have some certain functional block. So that comes under the category of multiplexers, decoders, etc. They have a specific function which can be done. Okay, then you have sequential circuits where it depends on what is the input, how your output will change, as well as what is your previous data as well. Okay. So sequential circuits, latches, flip-flops, also we will see. Then, application or example of sequential circuits, that is counters, shift registers, etc. Okay, actually Devraj Patil, actually 100 students is the limit for this Zoom. I'll have to actually buy Zoom Pro if I have to increase the limit. So I'll request if anyone has joined with two names, like has joined two times, kindly, disconnect from one of your devices. Okay, so that other students also can join. Okay, next week we'll try. I'll get Zoom Pro so that we can increase the limit of the number of students. But for this week, I apologize. It could be 100. Okay. Okay. So then we will have week 8. We will talk of counters, shift registers, finite state machines, etc. And then we will have data converters, sample and hold circuits, ADCs, analog to digital converters, DACs, that is digital to analog converters. Then various memories, ROM, SRAM, DRAM. Okay, we will study about these things. Then a particular application microprocessor 8085, it consists of 2 weeks. Okay, so this is a very exciting subject, interesting subject which you will learn, which you will enjoy. Also, it is very, application specific. That is, you can see it, you can visualize the output and the results of it, and you can see how things work, etc. And it's also very important and also good scoring topic as well. Okay, so this is the thing, and this is an exciting thing. So where both you and I both can learn. Okay, and about this thing, some general information which I want you to understand is general information is this. So you can access the videos from the Swayan portal. So you would have logged in, you would have enrolled for this course, and actually today is the last date for this course enrollment. So you would have get Swayan portal, you can access this course. Then this is a UG core course for electrical electronics, VLSI design, etc. And it's a 12-week course. You will get 4 credit points. And enrollment that ends today. and the exam date is on 24th October 2026. That is Saturday. Okay, so approximately August, September, October, so 3 months. You have approximately 3 months for the exam. And but the last date for exam registration is 14th August at 5 p.m. So by that date, you have to register for the exam. So if you register for the exam, if you do good in the assignments and in the what you say the exam as well, there is certain criteria, certain things which I will also show in the future slides. So you can get a domain certificate. So this certificate is very useful. It could be come in handy for you. You can add it in your CV, and there are various things. There's something known as NPTEL stars also, which I will also show further. So there is an announcement section in this Swayam portal where you get the details of the week the content is released on the portal, when this meeting, this online, this weekly discussion, problem solving session will be there. That also you will get. As well as the discussion forum is something which I have not able to find. In previous years, there was a discussion forum where people will put their questions and doubts. Okay, but currently that discussion portal I'm not able to see. So how to apply for exam? Actually, that you can check in the portal. In the portal, on some top right corner, I remember seeing where you can apply. First, you have to pay for the exam, and you have to register for the exam. So let's see. Let's go further. So, as I said about the exam is on 24th October, a Saturday. Last date for exam registration is 14th August. So, if you register between 10th August to 14th August, there will be a late fee which will be applied. Okay, you can register, but a late fee will be applied. But if you register before 10th August, then the fees for the exam will be 1,000 rupees. Okay, 1,000 rupees is something which is there. 1,000 rupees is for general category, for other category students, for people with physical disability, the fees is reduced. Okay, so that's how you can get a certificate for this course. You have to solve the assignments. Okay, for the details are there. Then also this course, if you give, if suppose you're a professor or a teacher in a college or lecturer, this can come under faculty development program. If you want to get it as a faculty development program, you have to just give an extra nominal fee of around 100. That is 1,000 plus 100 for a general category faculty. Okay. There is also something known as NPTEL stars. That is, if you register for NPTEL course, you pass it, you get good marks, either you are the topper or in the top three on various other things, like in 3, 4 subjects, if you're done very good. There are various things, that is NPTEL superstar or NPTEL. There are many categories are there. The link is also there. So when I'll upload these slides, I'll upload the slides, I'll upload the notes which I write. Also, this video will also be uploaded on YouTube on a channel in which I will, my channel, I will upload this video. So there you can check out those videos as this video as well. The entire video, entire meeting will be recorded. So even if a student has not been able to join the meeting because of the limit of the number of students, they can go through the recording and then they can have it. If they have doubts, they can also put in the YouTube comment section. They can add their doubts as well. So for the exam, in the total marks, that is the total marks which are there, how it will break down is this: 25% of the marks come from the assignments. And the good news is the best of 8 from 12. Okay, so out of your 8 best assignment marks, 25% of the total marks comes. Okay, and 75% of the marks will come from the exam, where you have to go in person in a proctored exam. You have to attend and give it. From there, you get 75% of your marks. So total marks will come from that. But if you want to get a certificate, there is a minimum criteria for both assignments as well as exam. In the assignments, you should at least get 10 out of 25. That is the minimum. And in the exam, you should at least get 30 out of 75. So that you will pass. So even if you get 40 out of 100, that is in the exam, suppose you got 50 out of 100, and in the assignments you got 0, still you will not be eligible for the certificate, because this has been structured in a way that it encourages a student to regularly come, see the videos, and to test their own knowledge which they've learned by solving the assignment questions. And after going through the entire process of 12 weeks of learning step by step, one module after another module, you go and you test your overall knowledge with a complete proctored exam. Okay, so that's how this has been done. So this NPTEL is initiative of 7 IITs as well as IISc Bangalore and all. So this is for for students who are not as well privileged to get access to, how IIT professors teach, and they can get access to the knowledge. And one student actually commented that IIT professors teach better on NPTEL than in IIT. So you can be happy. Okay. So then, so for today, I hope you don't have any queries in this till now, till all this which we have discussed regarding the exam, regarding the general information and the course content. Is there any question, any query from anyone? Okay. Also, I'd encourage it to be interactive. Okay, I'll encourage it to be interactive. If you have doubts, kindly ask your doubts, and kindly do not what I say, write anything on the screen. Hmm. And ask your questions and ask your doubts. I'll try to address your doubts as well. Okay. So for today, we'll have the introduction. We'll talk what is difference between analog and digital. Like why are we going for digital? Then we will discuss regarding number systems. That is, now if you want to speak a language such as English or Hindi or something, you learn the alphabets, right? The what is the alphabets, and like A B C D, K K G G, all those things. Once you have those things, then you can further do the analysis. So like that, the basics for digital is you have the number systems. Okay. And since we need to represent numbers, we also need to represent fractional numbers. And in our day-to-day life, we have fractions, we have sign numbers, negative numbers, all those things. So for that, this week module is for that. Okay, it's for you to get started. It is a particularly easy part. What you can do? Okay, if I'm not Indian and live outside India, is the exam fee still 1,000 rupees? I don't know. I don't think it will be the same. There may be some criteria, some ratio. Uh, you could check on the portal. Okay, and in the portal there are various details. There are various documentation is there for which category has to pay how much amount of fees. All that information is there, so you can refer to the portal. Currently, I do not have that idea. Hmm. So, uh, I have also prepared some questions which we can do at the end. So let's start with uh, just some teaching part. Okay, assignment, how do you submit it is, uh, assignment, you have to click those buttons, like whichever is the ABCD option, etc. And you have to, once you click those buttons, then final you have to submit it. Okay, so what you do is you mark which question, what and all you have selected, you do the things, and then you submit. You have to submit it. Okay, and the exam will be offline. The exam will be offline. You have to go to a particular center, and you will also get your hall ticket. Okay, there are various things. They close the registration early because they have to do various things. They have to set up, they have to set up the centers. They have to set up what you say, which time and slots, everything are there. So for that, exam is offline and you have to register early. And you will get the hall ticket only 14 days before the exam. So they will take some time and their processing is there. Okay, sign and
सर
answer.
एग्जाम
Yes, yes, tell.
सर एग्जाम ऑनलाइन होगा ना?
नहीं नहीं, ऑफलाइन होगा, ऑफलाइन होगा। मतलब यू हैव टू गो देयर, वो एग्जाम सेंटर में आपको जाना पड़ेगा, और वहां पर ही आपको वो ऑनलाइन देना पड़ेगा। मतलब एग्जाम सेंटर को आपको फिजिकली जाना पड़ेगा, और उनका जो डेस्कटॉप या उनका जो मशीन में आपको उसका मार्क करना पड़ेगा, आंसर करना पड़ेगा।
जी 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 सर,
हम्म,
जी सर।
ठीक है, ठीक है। So I'm only limited to English and Hindi, but let's hope that that is sufficient for answering your queries. Okay, so signed and unsigned numbers we will come. It will come at the end. So we will slowly discuss what was taught and finish. Okay. Yeah, after finishing assignment, marks are not shown. For week zero assignment, you will get the marks instantaneously. Like how much what you submit, what is right, wrong, you will get to know. But when you go further for week one, week two, and all, you submit, you will not get the marks at that instant. After that submission deadline is over, then what will happen, they will release the answers sheet, like this was supposed to be the right answer, this was supposed to be the wrong answer, etc. And also there is some section in the portal where they will show that this much marks you have got in assignment 1, this much marks you have got in assignment 2, and so on. Okay, so I'd recommend you to go see the portal and check slowly. There are also various videos regarding what types of questions will come in the exam. You can have numeric answer type questions, you can have multiple choice questions and all. So those things are there. I'm not okay. No, assignment will not be sent by post. Assignment, you get an email saying that the assignment is there and that the assignment deadline will be on this date, and you have to go to the portal and you have to answer the assignment in the portal. Hmm. Okay. I am not joined week 0 and week 1. What can I do? No, week 0 and week 1, you can check. See, even if you have enrolled today is the last date of enrollment. Even if you enroll today or previous days also, there's a week 0 section and a week 1 section in the portal. So you can access the videos, you can access the assignment also. Okay. So one thing is my handwriting is not good, so you'll have to bear with me regarding that. But I hope you can understand. So digital circuits, and we will be talking of what is analog versus what is digital. Okay. So I hope you all are going through all the videos which sir has taught in week 1. So let us say you have a coin. Okay. Let us say you have a 1 rupee coin. Is it heads or tails? Is that an analog thing or a digital thing, that it is heads or tails? Is it analog or digital?
Digital.
Yeah, that is digital, right? That is digital. Yeah. Now you have a coin. Assume a coin is there. The coin could be 1 rupee, 2 rupee, 5 rupee, 10 rupee, or 1 cent, 5 cents. I don't know. In different country, what is the thing? So is that analog or is that digital?
Analog.
Yeah, that is analog. Correct. Okay. So now you have an exam. Okay, where you have a result. Result is, suppose, let us say you have you have enrolled in this course, and you go through all the weeks, you submit the assignments, then you pay the registration fees for the exam, and you go for the exam, everything, and then you either pass or fail. Is that analog or digital?
एनालॉग होगा
Digital.
सर
No, either pass or fail. या pass या fail. If you pass or fail, is it analog or
Digital.
digital?
Digital.
Digital, that is digital. But suppose you got 40, 60, 50, 100 marks. Is that analog or digital? Yeah. Your marks will be analog, right? Your marks will be analog. Okay. So in the real world also, there are certain things which are digital, few limited quantity, but the majority of the things are analog. Okay. Majority of the things are analog. So there are various things like, you do addition, like you have various circuits, analog circuits, which, do they are amplifiers are there, or filters are there. Okay, they can be analog, and accordingly also we can have certain digital circuits which do that as well. Okay, so why, if the real world is an analog, why are we going to digital? There should be some advantage or some benefit which someone will get, that they're taking all that effort to go from analog to digital. Okay, so what are the benefits of digital? Yeah, you can tell. You can tell. Okay, good. So one very important thing of digital is your memory. You can store information. That's good. Next, what is another benefit of digital? Okay, easy classification of immunity. कोई बोल रहा था? Someone is saying something? Okay. So one is classification also, which is good. Then noise immunity. So this is a very important thing. Okay. Like in analog, you could have, let us say your, this like 10.12. Something is 10.12. And then you add some noise. Let us say 10.12 volt, and then you add some noise of 20 millivolt. So then it becomes 10.32. And then on top of it, you do some multiplication or you do some processing, etc. That noise gets affected. That noise also could get amplified, could get boosted, something. But in digital, if it is zero, means it has a range that is between 0 to 0.3 volt, it is zero. Or between zero point 0.5 to 1 volt, it is one. So your signal can be between 0 to zero point 0.3. It could be 0.1, 0.2, 0.3. Still, then actual true value of that signal, which is zero, will still hold true. But, and if it is suppose it between 0.7, 0.8, 0.9, still in the logical sense, its value has to be 1 in digital and it is read as 1 in digital. So that is then why noise immunity is there. And in digital, what you can do is you can transmit that information in a better way. Okay. Then efficiency for long distance transmission, that's correct. And low noise also is there. Okay. So easy transmission. Okay. Long distance transmission, 4. So it's very good that you all have this idea of digital, that you know what are the benefits of it, and so you're also studying something which is very important and relevant also. Okay, so now in digital, one benefit is you can reprogram. In certain cases, you can reprogram. Okay, that same block, that same IC or that same chip, you can reprogram. And so okay. Yeah, so second point is classification. That is, you are able to say, is it 0 or 1? Not 0 to 1, sorry, 0 or 1. So classification and noise immunity are sort of linked. Okay. Classification and noise immunity is sort of linked. That is, you have a more, tolerance range. Tolerance range. Okay. So now in digital, you can reprogram it. It is also reconfigurable, right? In certain cases, for certain circuits, it can be reconfigurable as well. And like you, let us say you have a resistor. You guys know that the resistor has a certain tolerance, 10% tolerance, 20% tolerance. And then in your analog circuit, what happens? There is heating, temperature changes. And when that temperature changes, you know that the resistor value also will change. Similarly for capacitor, inductor, all that. But in digital, it is much less. That is, if you have programmed that this value is going to be this much, and then it will add and it will subtract and it will come this much only, then it will work accordingly. Okay. So there is a certain benefit, a certain, ability or longevity of digital circuits in that aspect. Okay. So these are benefits of digital. So in digital, we have, how do we represent information in terms of bits? And bits is what? Either 0 or 1. Okay. It is either 0 or 1. So that gives rise. So just 0 or 1 is not useful information. It's not of any use, right? You need to have more information. How do you represent information like that? So for that, you have binary number system. Okay, so I'd like to tell you guys that this meeting will end in 10 minutes. And because this is not Zoom Pro, I'll have to restart the meeting and you'll have to rejoin. Okay, so this is a kind of bottleneck which we have. So let's see if I can get Zoom Pro next week so that you guys don't have to face that issue. Okay, that so that it can continue. But this class, uh, you'll have to join. Like after 10 minutes, the meeting will end. I will again restart the meeting and then you can accordingly join as well. The link will remain the same. So don't worry about that. Okay, so binary number system. And let me also, before that, uh, so I have shared the YouTube link of my channel where I'll be uploading the videos. Okay, so you can you refer to this YouTube channel for seeing the videos. Okay, so there may be some network issue. Currently, many students were not able to join this session. So you can refer to the YouTube channel to see the recording of this video. Okay. All right. So now in the binary number system, you go from, let us say, 0, 1, 2, 3, 4, 5, 6, 7. Okay. So 0, you represent it as 0. 1, you represent it as 1. But 2, how do you represent? How do you represent 2 in digital? Can anyone tell? Yeah, 2 is 1, 0. 2 is 1, 0. 3, how do you represent 3? 1, 1. Correct. For 4, you have to represent it as 1, 0, 0. For 5, you'll have to represent it as 1, 0, 1. Right? For 6, it is 1, 1, 0. And for 7, it is 1, 1, 1. Okay. Yeah. So now, if you want to represent between 0 to 7, you have to have 3 bits. Okay, 3 bits you have to have. Okay, you have to have 3 bits, right? 3 bits you need to represent between 0 to 7. And this is like an unsigned number. Okay, this is unsigned number. All right. So let us try to understand number systems. Let us try to understand what is number system, what do they represent, what do they actually mean. So let us take the number 123. Okay, 123. So if you have this number 123, then what it is made up of? 1 into 10 raised to 2 plus 2 into 10 raised to 1 plus 3 into 10 raised to 0. This actually is the number system. So your 123 is actually equal to 123 is actually equal to 100 plus 20 plus 3. Okay. So if you look at 123, this actually is 3 you multiplied by 10 raised to 0. 2 you multiplied by 10 raised to 1. 1 you multiplied by 10 raised to 2. And then you add it. Okay, then you add it. So let us look at a number which you guys have told that in digital its number is 6. Let us say 6, which is in decimal this way. You have to represent it in binary, which you guys have told it is 110. Okay. So 110, how it is? Actually, it is 0 into 2 raised to 0 plus 1 into 2 raised to 1 plus 1 into 2 raised to 2. Right? So this is actually 0. This is actually 2. This is actually 4. When you add them together, it becomes 6. Okay. So is there any confusion in this point till now? Okay. So this seems very easy, but this is something which you need to like keep it in the back of your head. What actually it represents, what actually it means. Okay. So let us take a bigger number, slightly bigger number. Let us say we take 26. Okay. Before that, I forgot to tell something. Since you're going to work with digital and you're going to work with binary, I'd recommend you by heart this. Okay, you by heart this. Okay, Santosh Kumar, please do not add any annotation here. Okay, it is not erasable.
Sorry, sir. Sorry.
Okay, okay.
By mistake, it has happened.
Okay, can you try replacing because it is stuck. It is not going away. I can't erase it.
Okay.
Okay, okay, thank you.
Okay. Sorry, sir.
Okay, so you need to know this. That is 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4. I recommend you by heart this. 2 raised to 3 is 8, 2 raised to 4 is 16, 2 raised to 5 is 32, 2 raised to 6 is 64, 2 raised to 7 is 128, 2 raised to 8 is 256, 2 raised to 9 is 512, and 2 raised to 10 is 1024. Okay, this number range would be good. You could also do 2 raised to 11, that is going to be 8402048, and 2 raised to 12 is 4096. Okay, so this is something you should try to recall, you should try to know, or at least you should be able to calculate it quickly. Huh? Because suppose I tell you have to find the number 25. 25, you have to find it in this binary representation. So you need to know how many number of bits. So if I want to represent 25, how many bits do I require? Can anyone tell me?
Sir,
If I need to represent the number 25, can anyone tell how many number of bits do I need?
which
Huh. Okay, people are saying 5 bits. Okay, 5 bits, correct. I need to have 5 bits. 1, 2, 3, 4, 5. Okay, because it is less than 32. So I need to have 5 bits for it. Okay, now I have 25. Now I have to add. Okay, I have to put the bits. I have to put the value of the bits. So first, so this is what 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. Okay, so 2 raised to 4 is 16. So is 25, like thus when you add, when you subtract 16 from 25, is it positive? Yes. So I will take this as 1. Okay, so now when I've written this, it has become 20. Okay, it has become, I've considered a ratio value of 16. So it has become 25 minus 16 I have done. So I am left with how much? I am left with 9. Now I go to 2 raised to 3. That is adding a number of 8. So if I subtract 8 from it, will it still be positive? It will still be positive. So that's why I'll add a 1 over here. So I'll do what? 1. So then I'll do 9 minus 8. I'll be left with only 1. So for only 1, what I have to do is I just have to make this 0, 0 and this is 1. Okay. So this was a general way, intuitive way, but then there'll be a structured mathematical way, which we will also look into. So any queries in this? Okay. Kindly mute yourself. Nandini, kindly mute yourself. Yeah. Okay, Nandini, Konda, could you kindly mute yourself? Okay. Okay. So let's start with like we have 25. Okay. We have to do repeated division of 25. And we have to, sorry, we have to get the quotient and remainder we have to do. So if you divide 25 by 2, what do you get? Okay, so let me say you have 2 and you have 25. You're dividing 25 by 2. Okay, so what you do, 2 into 1 is 2. So you take 1 over here. So 2 minus 2 becomes 0. Then you get 5 here. Then what you do multiply by 2. So it becomes 5 minus 4. That is 1. So what happens is uh, your remainder is 1 and this is your quotient, right? This is your quotient. So when you do this repeated division, what you will get over here, you will get 12 over here and your remainder is 1. Okay, your remainder is 1. Is there any query in this? Because this is important. This is something which you have to use when you want to convert decimal to binary or to octal or to hexadecimal. You need to know this. Okay, so is there any query in this? Okay, so I trust you guys know have understood this. Okay, just one ready, please kindly don't put any marks on the screen, please. Okay, so now let me divide it by 2 also. Okay, when you divide it by 2, again you divide it by 2, what you get? You get 6, but the remainder is 0, right? Then you again divide by 2, what you'll get? You'll get 3, but the remainder is 0. Then you again divide by 2, you will get 1, and the remainder is 1. Then you again divide by 2, you will get 0, and the remainder is 1. Okay. Yeah. So just one, can you kindly remove it? Can you rub it off? Because I cannot remove that. Okay. So now, once you have done this repeated division, so what is this called repeated division? Now you have to take it like this. So your number actually will start from, so this will be your MSB, this will be your LSB. Okay. So what you do, you take it like this. You take this here 1, then this will come here 0, this will come here 0, this will come here 0, and this will come here 1. Okay. So this is known as your most significant bit. This is known as your least significant bit. Okay. Okay. Uh, Kas, Akshara, you can actually check again because are others able to see the screen? Is there any issue in the screen? Okay, you're able to see the screen, right? Yeah, yeah, yeah. Okay, fine. Okay, so the way you convert 25 into a binary representation. Okay. Oh, sorry. This will be so this will be 11001. Okay, I'm sorry. So that's why 25 in a decimal thing gets represented as 11001 and 2. So let me ask you guys to do something. So let us say what would be the binary representation for 62. Okay. Can you guys do it and let me know? Okay. So how did I get LSP? What do you mean LSP? Or LSB, right? Konda Richita. So what I've done is I've repeatedly divided by 25, I've repeatedly divided by 2. So in my let me go through it again because this may be something which is confusing. So 2 divided by 25. When you do repeated division, you get what is known as a quotient. This is your quotient. And this is your remainder. Okay. So your quotient which is over here comes over here. Okay. And your remainder which is over here, it will come over here. Okay. Then again you divide 12 by 2. You will get 6 as your quotient, but your remainder will be 0. Right? So your remainder is 0. Then you divide 6 by 2. You get 3 as your quotient, but your remainder is 0. Then you divide 3 by 2. Your quotient will be 1 and your remainder will be 1. And then again you divide 1 by 2. Your quotient will be 0, remainder will be 1. Okay, so all of you guys have given me the number for 62. So very good. You guys are very fast. Okay, so let me take what is your answer? It is 111110. Okay, you guys are. I think I gave a very simple question. Okay, so let us try something difficult, something bit more challenging. Let us try with 135. Okay, what will that value be? Is just we saying all once? Someone is saying one. Okay, there are many answers coming in. I think there should be an option of a pool or something. So that way we can get a collective answer that which answer is more number of participants are giving, and then we can do. Okay, so that also is a thing we can check for next class. So most answers which I'm getting is 1, then 1, 2, 3, 4 zeros, and then 3 ones. Okay. 1. Okay. So the answer which I've got a lot. Okay, if screen is not visible, it's blank only. I don't think that's a problem for others. Probably maybe you have seen the something else or something is coming. Okay, so let us say the answer which most of you are giving is 1,000,000, and I think 4 ones are there, right? No, 4 zeros and then 3 ones. Okay. So you have 4 zeros and 3 ones. So how do I check? So this will be 1, this will be 2, this will be 4. Okay, this will be 8, 16, 32, 64, 128. So that is 128 plus 4 is so 132 plus 2 is 134 plus 1 is 135. Okay. So that way the answer is the correct answer. So very good. So you guys are able to do things good and fast and everything. So let's make it more difficult because you guys are doing very fast. Let us take the number 1289. Can you find for this? For 1289, can you find the binary representation of this? Okay, some of you are super fast. I don't know what you guys are using, whether ChatGPT or something, or online tools, but you guys are very, very fast. So it is so the answer which many people are saying. Let us see. Which people are saying is 101, or maybe I'm underestimating you guys a lot. 1010. Then there are how many zeros are there? 1, 2, 3, 4, 2, 3, 4, 101. Yeah. Yeah, it takes a little bit more time because there are more number of bits, but you guys are pretty fast. I didn't expect you guys to be so fast. Okay. So now, if you want to do this, like if you want to convert this from decimal to binary, you have to divide by 2, 2, 2, 2, 2, 2, 2 again and again and again and again. What if you divide it by 8? Let us say you have 1289, and instead of dividing it by 2 each and every time, let us divide it by 8. Okay? Let us divide it by 8. So I'm not that great at math, so let us try doing it in this format. So you have 1289, you're dividing it by 8. What will you get? So first 1, so 12 minus 8 is 4, so 48. Okay, 48. So this again minus 48, 16. Okay, this becomes 0, 9 is left. It is 1, so minus 8 becomes 1. So what happens is this is your quotient, this is your remainder, right? So you get what you will get over here now. You will get 161 here, and you will get 1 over here. Okay, you will get 1 over here. Now, again, I divide by 8. Again, I have to divide by 8. If I divide by 8 now, what I have 8 divided by 161, right? What I have to do? It will become minus 16. So 2, so 0, and then 1. So you have got 2 here and you have got 1 here. So your quotient is 2, your remainder is 1, right? Very good. Then again you divide by 8. Then your quotient will be 0, your remainder will be 2. Any questions regarding this? Regarding what I've just done over here? Is there any question? Like I have divided by 8. And when I divided it by 8, the number of times I have to divide has reduced drastically. Okay, it has reduced a lot. So is there any error in my division, multiplication, anything? Let me know. Just see it for 1 minute and let me know. Okay, but please don't mark, please don't write on the screen. Just tell me, I'll do the writing. Okay, so I'll assume that the silence says that people think it is all correct. Okay. So now, what have I actually done? So this is for your octal representation. This is for octal. If I want, okay, it is, my handwriting is bad. Sorry.
Hello, sir.
Yes, yes, yes.
161 divided by 8, the quotient is 20.
Oh, yeah, yes. I'm so sorry. Correct, correct. Thank you. Okay, 20. So, right. So 20. So, so that is correct. So now I have to do another division. So 8 divided by 20. So this is 16. So 4. Correct. Thank you. So when I divide 20 by 8, what do I get as the quotient is 2, remainder is 4. And again, when I divide it by 8, the quotient is 0 and the remainder is 2. Okay. Thank you. Thanks a lot. Because the answer would have been wrong. Thank you. Yeah. So this is what has happened. The number of divisions changes when you go from binary to octal representation. Okay. So now if I have to represent this number, this large number, this 1, 2, 8, 9, 10, in the octal representation, based on what we have got, it is 2, 4, 1, 1 in terms of 8. Okay, so let us see whether this division, which is prone to human error, whether it is correct or not. Okay, so how do we do it? So we have 2, 4, 1, 1. Okay, and since this is in octal, it is in the powers of 8. So this will be multiplied by 8 raised to 0. This will be multiplied by 8 raised to 1. This will be multiplied by 8 raised to 2. And this will be multiplied by 8 raised to 3. Okay, so let us start simple. So 8 raised to 0 is 1. So 1 into 1 is 1. So this is 1. Now 8 raised to 1, that is what? Regarding this, 8 raised to 1 is 8 into 1. That also comes out to be 8. Then regarding this, 8 raised to 2 is how much? 64. Now 64 into
256, sir.
256. Very good. Thank you. So you get it as 256. Okay, 8 raised to 3 is how much? Let me know.
512, sir. 512.
Okay, 512. 512 you multiply by 2 is how much?
1024.
Correct. So you get 1024. Now you add all these together. What will be 1 plus 8 is 9, plus 6 is 15, plus 4 is 19. So you get 9, carry 1. 1 plus 5 is 6, plus 2, so 8. Okay, then you get 2, then you get 1. Okay, so magic. Like this is like the magic show, right? So is this clear or you want me to repeat it again? Or just to make it simple, some people may be shy, don't want to ask questions. So let us try once more. So what I showed was, if you want to convert a decimal number to binary, you do repeated divisions by 2. 2, 2, 2, 2, you divide. You store the string of your remainders. And then the very last remainder which you have, from that onwards, you write. That is your MSB. And then last one is your LSB. Sorry. The last one is your MSB. And the very first remainder becomes your LSB. Okay. So this is when you're dividing it by 2. Then when you increase the number, 25 is easy. Okay. You can do it by some mathematical thing, everything. By intuition, you can do 62, you can do 135, you can do 1289. Also, many of you did quite fast. But if you went to the hard way of dividing by 2 repeatedly, it will take lots of time. So what if you divide it by 8? When you divide it by 8, it will, it will reduce that amount of number of divisions by a large amount. Okay, it reduces it by a large amount. But still, that method where this will be your most significant. Okay, and this will be your least significant, still is the way. So that's why the 1289 in decimal gets represented as 2411 in octal. Okay. And then just to, check whether something like someone pointed out that I had made a mistake, and that was very good that she pointed it out. So similarly, just, for confidence, for checking whether what I've done is correct, I have written in terms of 8 raised to 0, 8 raised to 1, 8 raised to 2, 8 raised to 3. Done the multiplication. So 8 raised to 0 into 1, so it comes 1. Then I've got here 8, 256, 1024. And then I've added all these, and then I got it to be 1289. Okay. Right. Okay, so this is a way, and this is one thing we can do. That is 1289. So now it comes to octal. Okay, now we are looking at what is known as octal. What does octal do? Octal also is kind of similar to decimal. That is 0 is 0, 1 is 1. So let us say, let me rub it. This is your decimal and this is your octal, right? 2 is 2, 3 is 3, 4 also is 4, 5 is 5, 6 is 6, right? 7 is 7. Till here, octal and decimal look the same. The thing starts from 8. 8, how do you represent 8? 8, you represent it as 1, 1. No, sorry, it is represented 1, 0. This is how you represent 8 in octal. 9, you represent it as 1 and 1. 10, you represent it as 10, how do you 1 and 2. Okay, like that it goes on. 11, you represent as 1, 3. 14, you represent as, 12. 12, you represent as 1, 4. 13, you represent as 1, 5. 14, you represent it as 1, 6. And let us go here. 15, you represent it as 1, 7. 16, you will represent it as 1, 0, 0. Okay, 17, you will represent it as 1, 0, 1. Okay, and so on. This is how it will continue. Okay. Any questions in this decimal to octal? Okay. So very good. You guys are learning very fast. So so let us see. We had chosen a number that is 1289. Okay. In the binary thing, what did you guys tell? What was the number? Can you all repeat again? 1289 in binary. What was the number? I'll have to go to your chat. Okay. It is 101, then 40 and 101. Okay. So it is 101, then 4 zeros, and then 101. Then 1001. Okay. 1001. Okay. This is in binary. Now, suppose you have got it in binary. How do you convert it into octal? So, if you want to convert it into octal, what is the way for you to do is you take, starting from the LSB, you take 3 bits, 3 bits, 3 bits, and 3 bits. Okay. And then now 001. In octal, what it is? 001 is actually 1. 001 again also is 1. 100 is actually 4. And this actually will be 010. So that will be equal to 2. So it is 2411. Is that what you got previously in octal? Let's check. Yeah, we had got 2411. Right? So let me repeat again. But I think this which I wrote was confusing for you guys. Let me repeat it again. Let me just show. This is decimal, okay, binary, and then octal. How you represent in decimal, binary, and octal. Let's start with some number 5. Take the number 5. In binary, how you represent it as 101. Binary. In octal, you represent as 5 and 8. Let us take the number 8 because it's a bit difficult. 8. 8. Sorry. You represent it as 1000 in binary. In octal, how do you represent it as 1 0 in octal? Take the number 15. Okay. 15, how will you get? 15 is 1, 1, sorry, 15 is 1, 1, 1, 1, 1. Right? In binary. In octal, 15, what it will be? It will be 1 and 7 in octal. Okay. And how can you get that? How can I write that? Oh, there's a mistake. 15 in binary, is it this? Can you guys say 1 plus 2 is 3 plus 4 is 7 plus 8 is this? Yeah, sorry. This is it. There's 0, 1 here. And here also. Okay. Right. Yeah. 16. Okay, let's see. So now this, you group this. Sorry. Zero, 0 here. So now you group 3 bits. You group 3 bits here and you group 3 bits over here. When you group these bits, this actually represents 7 and this represents 1. Okay. Suppose you take the number 16. Take the number 16. In binary, how you represent it as 0, 1, 2, 2, 4, 6, 8, 16. Like this, right? This is how you represent it in binary. And in octal, how do you represent it as? You take 3 bits here, then you take the next 3 bits. This 3 bits is actually what? Accounts to 0. This 3 bits accounts to. We're making a mistake. 1, 2, 4, 8, 16. Sorry. Sorry. This will be 0, 1, 0. And so this actually in octal, it's actually 2, 0. Okay. So you have 16 when you represent it in binary, it comes 0, 1, 0 and all zeros here. And then in octal, it becomes 208. So any questions in this one? Or any mistakes? Okay, kindly don't write on the screen. Yeah. So now this is an octal. Next, there is something known as hexadecimal. So it becomes a little bit complicated. Hexadecimal. So let us say you have in decimal and in binary and in hexadecimal. How it goes over here. So here you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? You have the binary representation of it. Hexadecimal also remains 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Till here, it is simple. Okay, one more time, what I should tell? The octal part. Okay, for just a brush up, let us say the octal part, how do we get? Decimal, you have 5. In binary, you represent it as 101. So what you do, you club 3 bits at a time. And this you represent it as 5. Okay, because its representation is 5. When you go to 8, you have 3 bits over here, all 0. And then here you have to append 3 bits, that is 0, 0. And then you get another 3 bits. Right? So all the zeros become 0. And this 0, 0, 1 is actually 1. When you go to 15, it is represented like this in binary 0, 0, 4 ones. You take this 3 and then you take this 3. So this becomes 1 and 7 in octal. So similarly, 16 also you can write. Okay, I hope that has cleared your doubt. So till 9, so let us go back, let us go to hexadecimal. Okay, let us go back to hexadecimal where you have decimal to hexadecimal is 0 to 9. That remains the same. But when we go to let us say we go to 10. In binary, what it becomes 1010, right? In hexadecimal, we write it as A. 11, it becomes 1011. Hexadecimal, we write it as B. 12 becomes 1100, you write it as C. 13, 1101, you write it as D. 14, it becomes 1110, you write it as E. And 15, you write it as 1111, that becomes F. Okay? Yeah, correct. So this you must remember that 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. Okay? If you're not able to remember, you must carefully, quickly, identify that this is this, and so on. All right? So what happens if you get number 16? If you get number 16, what it is? It is 16 actually is equal to 1 and then 4 zeros, right? And that is actually equal to 10 in hexadecimal. So how it came? You club these 4 zeros and this you do as 001. So that's why it becomes 1 and 0. Okay. Let us say, let us do number 23. 23, let us find the binary representation of that. What is 23? Let us say 1, 2, 3, 4, 5, 6. 16. So this will be 1, 16. Then it will be 4. So 16 plus 4, 20. This is the representation of this. This is a representation of 23. Correct. You are grouping 4 bits for hexadecimal. So then you have got it in terms of 1, 2, 3, 4, 5, 6 bits. But it should be in set of 4 bits. So that's why we add another 4 bits over here. Okay. So what we do then, now we have this 4 bits and this 4 bits. So what is the number 011? Is actually 7. And what is the number 01? 001, that actually is 1. So this is in hexadecimal, you write it as 17. So 23 in decimal becomes 17 in hexadecimal. Okay. Yeah. Fine. So now we have seen binary, decimal, octal, hexadecimal. Let us say, how do you represent a number? Let us say you have 2.25. How do you represent that in binary? How can you convert 2.25 into binary? So to do that, let's start. You do this actually equal to 2 into 10 raised to 0, right? Plus 2 into 10 raised to minus 1 plus 5 into 10 raised to minus 2. So that actually is equal to 2. This is actually 0.2. That this is actually 0.05. So it effectively adds up to be 2.25. So what we are doing, we are breaking down that number. We are breaking down that number. Okay. Now, if you want to convert it to binary, instead of it being 10 raised to 0, 10 raised to minus 1, 10 raised to minus 2, it gets multiplied by 2 raised to minus 1, 2 raised to minus 2, so on and so forth. Okay. So to do that, we will first, how you tackle this is, you just consider 2, the integer part. 2. How do you represent 2? 2 is actually represented by, this is the integer part, and 2 is represented as 1, 0. Okay. Now, yeah. Now you have to go to the fractional part. Yes, people, many of you know, very good. So the fractional part you will be looking at is 0.25. So as I told, you need to know the powers of 2 raised to 1, 2 raised to 2, and so on. You also should be well versed with the negative powers to some extent. So what you should know, 2 raised to minus 1 is what? It is 0.5. 2 raised to minus 2 is what? It is 0.25. 2 raised to minus 3 is what? It is 0.125. 2 raised to minus 4 is what? 0.0625. Okay. These things you must have a fair bit of idea. All right. So that's why this 0.25, how do you do? You multiply it by 2, you will get 0.5. So 0.5 you got, you take this part, you take it over here 0. Then you have again 0.5, you multiply by 2, you get 1.0. So this is actually 1. So your fractional bit comes out to be 10.01. Okay, 10.01. So this was a very simple one. This meeting will end in just some 10 to 20 seconds. Then I will again restart the meeting in the same link. So you have to join in the same link. Okay. We will restart on the same link. So that time we will try a little slightly difficult question. And if you have any queries, let me know. Okay, how many digits after decimal? Okay, I'll show. Okay, so we were doing the fractional part. So let us start with a question. How do we represent 12.328 in terms of binary? Okay, 12.328 in terms of binary. So 12, you guys are well versed. 12 in integer. How do we represent 12 in terms of binary? Can anyone tell me? Yeah. Actually, I am from IT Kharagpur, and I'm a PhD student. Okay, and as you'd like to know where I am from, even I'd also like to know where you guys are from. So if those who are confident, they can also tell where they are from, what they are doing, what they are studying, what is their, why have they joined such a course? Are they a teacher? Are they a BTech student? What student? From which country also you can let me know. So you can, if you guys can introduce yourself, it will also be very nice. Okay. So Santosh is from Anantapur, from Ikrit. And what are you doing? Like a student, first year, second year, what are you doing? Or you're doing this to prepare for GATE? You can let me know as well. Okay, you're third year BTech student. Okay, so Santosh Kumar has introduced himself. What about others? Others also can introduce those who are willing. Okay, Santosh is
Hi,
also.
my name is Srinivas.
Okay, tell. Your name is Srinivas. Okay.
Srinivas Larigila. I am from
Okay.
Tirupati. I am
Okay.
working as a faculty in engineering college.
Okay. So you will be trying to get the faculty development program certificate or something?
Yes, sir. Yes, sir.
Okay. So Shreya is from
Thank
Shirpur. Okay, thank you. Yes, yes, thank you. Okay, Shreya is from Shirpur. So what about others? You can tell your branch, your year of study also. So wow, so many responses have come now. So Bijam is from Gidalur, fourth year college ECE. Someone is from Tanjavur. Okay, Tanjavur is Tamil Nadu. So Navneet is from Solapur and Polytechnic, aspiring cloud computing or embedded engineering. Okay. Then Tejasvi is from Chennai, BE, electrical student, second year. Okay. Aishwarya is EC, second year student. And someone has got the answer also. Thank you. Then Pratibha, second year ECE student. Revan from Hyderabad, ECE, second year. Okay. Akshara is Chennai, ECE, second year. Mati is from Tamil Nadu, second year. Okay, very nice. Shreya is ECE student. Uma Malini is from Thothukudi, BE, ECE, second year. Okay, Prithvi is ECE, second year. Selavami, second year VLSI. All right. So Gracious is from Zimbabwe, transitioning to electrical. Okay, very nice. Thank you for joining. You're adding a global perspective to our class. Prince is Nirmala D from Chennai and working as a faculty in engineering. Okay. Yaswini from Madurai, EC second year. Okay, Santosh has started very good. And Indu from Vizag, Harshita, second year EC student from Badagara. Eswar is Akhileswar from second year EC Raghu Engineering College. Indu is a third year EC student. Anu is first. Okay. Akshara is EC student, PSR Engineering College. And Sinu is Musla A. Okay. So very nice. I really enjoyed your introduction. There's also G. Ashika, second year EC student from Kudalur. Okay. So I'm finding out that there are lots of second year EC students and faculty is also there. Someone is from Zimbabwe also is there. Third year students also are there. So Ramya is second year VLSI student. Okay. So I'm also actually from Tamil Nadu. I I don't know Tamil. That's another thing. But I'm also from Tamil Nadu and I stay in Mumbai and I'm doing my PhD in IIT Kharagpur. So I'm all over, not exactly from some place. So, but yeah, we know we are related. We are joined together by NPTEL in one course. So I hope it'll be useful. You all can continue. You can give me feedback if you think I'm going too slow, I'm going too fast, my words are not clear, I'm very soft, or my handwriting is poor. I can't help that, but you can let me know. Okay. And yeah, you can unmute. You can also ask me questions. It's very nice when it's interactive. Okay. And I also like the enthusiasm. People are giving answers and everything. So yeah, when I was doing BTech, I remember like in the class, in tutorials, everything, there'll be that competition. Who will give the answer first? Okay. So that kind of competition is good. Yeah. But do it honestly. Huh? Don't use all your AI and everything and give the answer. I want you guys to do it honestly. Okay. So we had a very nice introduction from so many of you guys. Uh, Hopefully, throughout the course, we can get to know each other better as well, and we can make the course interactive. Okay, Yamuna, kindly please don't add stuff here on the screen. Kindly remove that, delete that part. Okay, so let us say 0.328. Let's get back to our questions. 0.328 we want to find. Yeah. So 12 you represent it as 1100. Now 0.328 we want to find it in binary. Okay. So when you want to find 0.328 in binary, remember when we were converting a decimal number to binary, we were doing repeated divisions. But now in this case, we will be doing repeated multiplication. So that is 0.328 we will multiply it by 2. Okay. Let us multiply by 2. What will we get? We get 6 and 1. 2 into 2, 4 plus 1 is 5. 2 into 3 is 6. So this is 0.656. Okay. Now, what is in front of the decimal? That is this number. So that we will note down. We will write it as 0.0. Okay, 1100.0. So now let's go to the next. So still we have 0.656. Okay, sorry. 0.656 we multiply it by 2. So what do you get? You get 2, 1, 10 plus 1, 11, 1, 1. 2 into 6 is 12 plus 1, 3, so 13. So it becomes 1.312. So now it has become 1.312. So already someone has got the answer, but we are still solving so that others can also understand. So 1.312, we'll take this 1 over here. So you get over here 1. Okay. Now what to do? You have to take the fractional part only. You have to focus on the fractional part. So you focus on what? 0.312. That one part you have added it over here. So now you have 0.312. You again multiply it by 2. What will you get? You get 4, then 2, then 6. So you got 0.624. So again you take this 0 over here. So it becomes 0 here. Then again you do this. You have 0.624. So Samsung, please don't write anything here. So 0.624 into 2 becomes what? 8, 4, 12. So 2.1. Okay.
Sir, can I know for how many times we need to repeat this procedure?
Yes, that's a very good question. Okay. So let's just do. So you got 1 over here. You put 1 over here. Now it is not ending, like we are going on, going on, going on and multiplying, right? And still we have not got the correct answer. So let us just try one last time. One last time. Let's say you have 0.248, right? You multiply it by 2, what you get? You got 6, 1, 4 into 2 is 8, 9. So you get 0.496. So again, so now you got as 0 again. Okay. So this is okay, 0. Then again, if you multiply, it will again come 0. Then again, it will come 1 and so on. It will extend. It will keep on extending. So how you must know to what limit you must get is, they will tell you whether you want an 8-bit number or a 10-bit number or a 12-bit number. They will say, okay, suppose in the question said you need to get an 8-bit number. It says you have to get an 8-bit number. So if you need to represent this information to a good accuracy, to a good amount of accuracy, you need 8 bits. They say we want the number to be represented at 8 bits. So then you will consider these 4 bits. Okay, these 4 bits are gone. And then you will consider these 4 bits. And the rest of the bits you neglect. The rest of the bits you will neglect. Okay. So if we do this, what we are doing is, they have told us the number should be in 8-bit format. So we have to represent the number. So we will represent all those integer bits as much as possible. The integer bits you must represent, because the integer bits is what is, dominating. It is setting the magnitude of your number. Okay. The fractional bits, the small points, they are like showing the accuracy, like to how much you want it to be accurate. Okay. So since we are limited, we are restricted to 8-bit number, we can only take additional 4 small, this fractional bits. But if you extend it to make it 10-bit or 16-bit or so on, you can extend the range and you can get a higher accuracy. All right. Any questions in that? See, I may talk very fast. I may say many things which you may not understand. So don't get worried. Okay, don't get worried. You can be happy that, okay, he's not a professional teacher. He's not a teacher. He's a student only who's teaching. So there are limitations in what I'm teaching. And secondly, you're also learning. So there are many things which you also don't know and which you'll also gradually understand. So what I've noticed is, like, people want to know everything one shot. I will sit now. I will understand everything in one shot. And if I understand everything in one shot, then only I like that subject. If I don't understand, I don't like the subject. That's not the way one should study. One should study once, one will understand some amount. Then you should go revise it. Then you will understand more. Then you go revise it, you will understand more. Okay. So it's like this. You are one shot, you understand what is the integer part. Next time you will understand the fractional part. Next time you will understand to how many bits you must represent. Okay. Like that, slowly, slowly you learn. Okay. And I'll also recommend you guys, like, don't, unless it's a big emergency, don't try to see all the videos of the lecture in one shot. It will not be good. Like, if at all, you could see one video per day. That would be better. Okay. That I think would be better. So one video per day you can see. Then you can spend one day in solving the assignment. And if you have any doubts and questions, you can join in this session and ask those questions. Right? Okay. Okay, Santosh had a doubt. Can you tell what is your doubt?
Sir, there you rounded 1.312, but again you're writing 0.312. Could you please
Yes.
explain that, sir?
Correct. Very good. So you got 0.656, right? Then when I again multiplied, I got it as 1.312. Now, this, if, okay, let us say this zero part, I already represented it over here, right? And this one part, also I've already represented that information over here. So once you put that information over there, I don't need that information anymore. And what information is left for me to represent is this 0.31. So I'll consider this represent information which is left to be represented, and I again do the multiplication. Okay. Okay, I'll again repeat. So, yeah, let me just give a repetition, because more repetitions, more you understand. So you got 12. How did you get 12? You may know it is 1100, but how do you do actually? You first subtract 8, you get 4. You see 4 is left, right? 4 is left.
Could you repeat?
Then you add the next one. So you get 8 plus 4, 12. So you know that information has been represented, and then you add 0. Okay. Please unnecessarily don't okay. Right. Okay, so you represented 12. Now you need to represent 0.328. So what you do 0.328 into 2. That becomes 0.656. Now that information 0.656, you take that 0 over here and you add it over here. So that level of information you have added, although it is, you have added that. Then the remaining 0.656, you again multiply it by 2, you get 1.312. And that value of that information, that 1, you write it over here. Okay, you write it over here. So what information is left for you to represent? 0.312. So again, you do 0.312 into 2, you get 0.624. And that 0, you add it over here. You added it over here, right? And then you so on, go on and so forth. So you have 0.624 left. 0.624 into 2 becomes 1.248. So that one information you add over here, and the remaining fractional part 0.248, you continue doing it. Okay. Okay. Yeah, don't worry, Santosh. It's not like I'm just banging you and repeating it to you. I'm repeating it for the entire class so that they can understand. Some students are there who will not ask down. Okay. I'm like that kind of student. So people are scared, people are shy, they don't want to ask question. People sometimes don't ask question because they think it is very silly question. That the teacher will laugh or that my friends will laugh. So people will laugh. Yeah, it's true. People will laugh. Students will laugh. Teacher also can laugh, but you will learn. No, so don't worry. Yeah. Okay. Yeah, it could be a disturbance. I'm sorry. Let's continue now. So we have done the fractional part. So let's start with something. Let us do represent negative numbers. Let us represent -5. -5, you have to represent it. So one is, you have 5. Let us consider 5. How do you represent 5? You represent it as 1, 0, 1. Since it is negative, right? There is a convention. There are 3 ways to represent negative numbers. One way is the sign magnitude way. Sign magnitude concept. One way is the ones complement. And the next way is the twos complement. So -5, how do you write it as? If you want to write it in sign magnitude, this 101, you will add a sign bit. That is this 1. Okay, 1 means it is negative, 0 means it is positive. So this is in terms of sign magnitude. If you want to find the ones complement of the number, okay, sorry, you have 0, 1, 0. In sign magnitude format, how do you write it as? You write it as 1, 1, 0, 1. Because this is the magnitude of the number, sorry, and this is the sign bit. This is known as the sign bit. If you want to get a ones complement, what do you have to do? You have to just flip the bits. So 0, 1, 0, 1 becomes 1, 0, 1, 0. Okay. And if you want to find a twos complement, what you have to do? You have to add 1, the last bit. So you will get 1, 1, 0, 1. This is your twos complement. Okay. So Revant, you're asking me to explain binary to fractional of the previous example. Yeah, I'll explain that. Just let me do this 2s complement part, and then I'll go back to the integer part. Okay. I'll do that. So I have considered an example. Let us say the number 5, but I have to represent a number -5. Okay. So in the form of bits, you represent it as 0, 1, 0, 1. Very good. Now, if we are considering it to be in terms of 4-bit number, then the most significant bit for a negative number will be 1. And the remaining is, because in sign magnitude, it will hold the magnitude as in the normal case. So it is 101. Okay, so this is the sign magnitude representation. If you want to find the ones complement of it, then you will take this 0101, the original number, and then when you want to convert to negative, you just flip all the bits. You just you pass it through a kind of an inverter. So you make it 1010. Now suppose you got the ones complement of it. Now you want to find the twos complement of it. So you just add 1 to the ones complement, and then you'll get 1011, which is the twos complement. Okay. So the twos complement one is the one which is very powerful, mostly used. Okay, Gracious, you have some doubt? Or you have raised your hand?
Yes, sir.
Yes. Okay, tell.
Yes, I want to ask, 5, is it 0101 or it's 101?
Okay. Okay. So 5.
I saw you wrote 0101.
Yes. Right, correct. So 5 is 101. This is in case there are only 3 bits. Okay. But in case there are 4 bits, then 5 is actually 0101. Okay. 5 is actually
Okay.
0101. Based on that.
Okay, thank you.
Okay. All right. So we have seen for 5. Let us try for some other number, little bit a bigger number, and we'll check. Okay. Let us try, go to next page. Number 13. Okay, let's try the unlucky number 13. It's not really unlucky. Some people think it's unlucky. let's try the number 13. 13, you tell me what is the binary representation of 13? Okay, correct. Very good. It is 111101. Good. 1101 is 13. But now I want to represent minus 13. You have to represent minus 13. So how will you do that? So how can you do that? Okay. Now, when you go to positive and negative numbers, when you want to include both positive and negative numbers, the range, the number of bits which you need will change. Okay. Suppose you wanted to represent 15. Okay, to 15. You just need 4 bits. If you want to represent 0 to 15, you just need 4 bits. But if you want to represent minus 15 to 15, you will need to require 5 bits, right? You need to add an additional bit. If you want to represent negative numbers, you need to add an additional bit. Okay. Yeah, many of you know the answer. Many of you are very fast. It's very encouraging that you're going to the videos. Good. Okay. So just for completeness, I'm explaining. So if I want to write minus 13 and I want to include minus 13 within the range, I need to consider 5 bits. Okay, I need to consider 5 bits. So what I'll have to do, this 13 which was here, I have to convert it into 5 bits. So it will become 01101. This is 13. Now I want to find minus 13, right? So in sign magnitude, what I will do is I will just flip the sign bit. I will just change this. I will just change this. And if I just change this, what will I be doing? I will be doing 1. So I'm saying that it is negative. And I'll continue with the same old set of bits, which represents the magnitude. So sign magnitude is the simplest. What does sign magnitude do? It just flips the sign bit and the magnitude, the remaining bits remains the same. Okay. Now, when we come to ones complement, when you take the ones complement, you do not consider this. Ones complement, do not consider the sign magnitude. Consider this. Okay, you consider the original value of 13 in binary. You consider that with an extra additional bit. Okay, because you're going to represent a negative number. And when you have that, you have 01101. What you have to do, you have to flip it. So you get what you get is 10010. Okay, you got a ones complement of it. Now you are told to get the twos complement of it. So you have to add 1 to it and you get 11001. Okay. Yeah. Okay, ones complement, let me repeat. Okay. So the first, like the most important thing, if you're going to convert a positive number to negative number, you have to do this. You have to get this. So this is like kind of your reference now. This is your reference now. So because you are going to represent a negative number, you need to have an additional bit. Okay, the range may be some value, but because you're extending the range to include a negative number, you add an extra bit. Okay, so if it is 13, positive 13, it will be 01101. If you want to convert to sign magnitude, you just flip the sign bit. But if you want to convert it to ones complement, you have to flip all the bits. The sign bit also gets flipped to 1. This 1 gets converted to 0. This 1 gets converted to 0. This 0 gets converted to 1. This 1 gets converted to 0. But the important point is you should get this. If you get this part, then you can do the rest. But if you don't get this, then it's an issue. So main thing which I want to stress again and again is you have to add an additional bit because you're going to consider negative numbers as well. So you take that positive number 13, you represent it as 1101, But because you're going to consider negative part also, you represent it as 0, 1, 1, 0, 1. Okay, once you get it as 0, 1, 1, 0, 1, if you want to convert it to ones complement, all those bits, you just have to flip them. So you get it as 1, 1, 1, 0, 1. Sorry, 1, 0, 0, 1, 0. Okay, and then if you want to get the twos complement, you just need to add in 1 to the ones complement. So you get 1, 0, 0, 1, 1. Okay. So any questions? Okay, yeah, there was a question by someone regarding fractional part. Okay. So let me do a recap of the fractional part because fractional part is quite confusing. Okay, if you're confused, it is confusing, right? It is not something which we have done many times, right? You have not been exposed that many times to a fractional number. Okay, so let us say you have 12.328. Integer part is very simple. You guys have got it. No issues in that. The fractional part. So you have fractional part that is 0.328. What you do is you multiply it by 2. Because fractional to converting it into this binary, you do repeated multiplications. Okay, you're doing repeated multiplications. So 0.328 into 2, you get it as 0.656. Right? Next, you will take whatever number you get ahead of the decimal point, that is going to be written. So you got 0 over here, you got 0 over here, you write 0 over here. Then what you have to consider is only the fractional part. Only the fractional part will carry forward in the next part. So you have 0.656, you multiply it by 2, you get 1.312. So what is comes to the integer portion, that is this 1, you will represent it over here. Your 1 comes over here. And then this 0.312, the fractional part will go in the next section. So 0.312, 0.312, you multiply it by 2, you get 0.624. You got 0.624, good. What you will do that 0 over here, you represent it over here. Okay. And then you will take the remaining fractional part and continue with the remaining fractional part. So you have 0.624, you multiply it by 2 again, get 1.248. So the one which you got over here, you represent it over here. And the 0.248 which you got over here, you continue and bring it over here. Okay. And so on, you will continue. Okay. So you cannot continue to infinity because you are a finite limited person. You have finite amount of time, and especially you have a finite amount of patience. Okay. So they will say that they want 8-bit or 10-bit or 12-bit. Depending on that, you can get the accuracy which is represented by the number of bits. All right. Okay, so I hope it has solved that question. And okay, very good. So let's try the other way. You have to convert it back to decimal. That I did not do. Let us say you have 10100.0110. You have this number, you want to convert it to decimal. You want to convert it to decimal. So what do you do then? You multiply this by, let's start with the integer. Integer is what we like. Very nice. We are very confident in that. Simple it is. Because we have done it many times, so it has become simple. So this you do multiply by 2 raised to 0. This you multiply by 2 raised to 1. This you multiply by 2 raised to 2. This you multiply by 2 raised to 3. This you multiply by 2 raised to 4. Okay. But in the fractional part, you have to multiply by what? 2 raised to minus 1. Then 2 raised to minus 2. Then 2 raised to minus 3. Then 2 raised to minus 4. So let's start. So anything which I multiply by 0, I can ignore that, right? I ignore that. I don't need it. I don't need it. So let me start with the one which is where you multiply by 1. So you should always remember that this point is like your reference. Okay, let's just start with the reference. Because we are focusing on the fractional part, let us focus on the fractional part. So what is 1 into 2 raised to minus 3? 2 raised to minus 3 is actually 0.125. So if you multiply it by 0.1, it becomes 0.125. Okay. Then let us consider, so we have already, what we have considered this. Now let us consider this bit. 1 into 2 raised to minus 2 is 0.25. So that becomes equal to 0.25. 1 into 2 raised to 2, let us say this one. So that is what? We have your point 0, sorry, point. So that is 4. And then let us consider this 1 into 2 raised to 4, 2 raised to 4, 16. So it is 16. Okay. Remaining thing you can, fill it up 0, 0, 0, 0, 0, 0, 0, 0, 0, and so on. You got that? Now you add them all together. You get 5, 7, 3.01, 20.375. Okay. Yeah. Okay, so this is a simple thing where you can understand these things. So we have done these things. These are the simple basics which you should get comfortable with, where you should become confident with. Okay. Yeah. Explain sign numbers. Okay, let me explain sign numbers again. Yeah, it is 20.375 in decimal. Yeah, thank you for reminding. So sign numbers, we will check. Let's start with a simple example. Okay. We will let us limit ourselves to something very small. If you want to represent a number 0, 2, plus 3, or let's say plus 8. Okay, 0 to plus 8. How many? No, you go 0 to plus 7. If you want to go to 0 to plus 7, how many bits do you need? You need 3 bits, right? You need 3 bits. But now, suppose you want to go from minus 7 to plus 7. Since you're increasing the number, you're doubling the number of numbers you want to represent, you have to increase 1 bit. So that's why it becomes 4 bits. Okay, it becomes 4 bits. So now, as it has become 4 bits, right? How do we go about it? So how do we go about representing a number? There are 3 formats which I mentioned. So let us take one number. Let us take the number. We already took the number 5, I think we took, right? We took the number 5. Let us take the number 3. Okay, let us take the number 3. Okay, number 3, and you have to represent it in 4 bits. So if you take the number 3 in 4 bits, that is plus 3 in 4 bits, what do you get? You get 0, 0, 1, 1. Okay, you got 0, 0, 1, 1. So now let us go to a simpler way. Let us go to one's complement first, because I think that was creating the confusion. Let us go to one's complement. So I have to go from here. I have to write it in terms of minus 3 in terms of one's complement. If I have to write it in negative number in one's complement, what I have to do? I have to invert all the bits. So 1 becomes 0. This one also becomes 0. This 0 becomes 1. This 0 also becomes 1. Okay. It's come here. Now I want to go to 2's complement. If I want to go to 2's complement, I have to add a 1 over here. And then what I will get? I will get 1, 0, 1, 1. Okay, this is known as the 2's complement. So the same number minus 3, same number minus 3. Okay, same number minus 3 In 1's complement, it looks like this. In 2's complement, it looks like this. Okay. And this same number minus 3, if I want to represent it in terms of sign magnitude, all I need to do is I need to just flip the sign bit. So 0 becomes equal to 1. And then you continue it as 0, 1, 1. Okay. This is in terms of sign magnitude. Okay. Any queries in this? So the meeting will end in 1 minute. I'll again restart the meeting where if you have any queries, you can let me know. Yeah, also I'll add the link for the YouTube video. Okay, so if there are no queries, we will end the session and we will meet next week. Okay, so thank you for joining. Thank you for your interest. I enjoyed teaching you guys. Thank you.